back to this channel. Myself, Rama AVABHRATA, Chemistry Department, SDM PU College, Annur. In the previous session, we had a discussion over the group 16th elements. Under that, compounds of group 16th elements. The one is oxygen. What we told in the last class, oxygen shows allotropy of group 16th element. All the elements of the group 16th shows allotropy. The allotropy of oxygen is nothing but ozone. Under oxygen, we discuss the what are the properties, what are the preparation method, and the oxide. There are several type of oxides: acidic, basic, and amphoteric. These three are the very important things. Some few are acidic, few are basic, and few one or two oxides are shows amphoteric nature. The most of all non-metals oxides, non-metallic oxides, carbon, nitrogen, so these are forms, or sulphur, like that. So these are the acidic oxides, and the metallic oxides from zinc up to the left side of the periodic table, the magnesium, calcium oxide. So these are the basic oxides, and aluminum oxide is the amphoteric one, and carbon monoxide, nitrogen oxide, nitrous oxide. So these are shows neutral property. So all these things we were discussed in the previous session. In this session, we shall move on to the allotropy of oxygen. That one is ozone. Okay, oxygen is over. Next is ozone. Ozone is represented O3 in the chemical formula. It is represented as O3 is a polyatomic, a triatomic state. The ozone is a well-known thing. I think most of you are known about these things, ozone and all that. Oxygen. Ozone is a layer, or the ozones, the molecules of ozones, they are present 20 kilometers far from the earth surfaces, and they forms a layer. These layers are generally formed from the oxygen. When the oxygen molecule, due to the heat energy, the oxygen molecule get combined and forms a ozone molecule. These ozone molecules and forms a one layer. Layer is nothing but only ozone molecule. It surrounds the earth atmosphere, and they prevent the large concentration of UV radiation that hits to the earth surfaces. O3. How these O3 are formed? Generally, O3 are formed from oxygen. How to manufacture O3? The O3 is prepared, the preparation method. Okay, the preparation method of O3 is using oxygen. Oxygen is passed through. Okay, let us discuss about the preparation. Preparation of ozone. Ozone is prepared from oxygen. Okay, stratosphere. In the stratosphere, generally they are formed from oxygen. It is 20 kilometer, more than 20 kilometer far from the sea surface or earth surface. In the laboratory preparation, or for the our uses for in different cases, like it is used as oxidizing agent and all that. In that cases, the ozone is prepared from oxygen. The oxygen is passed through, very important this one, oxygen is passed in a silent discharge tube, electrical discharge tube. The large quantity of pure oxygen is passed in a red hot electrical discharge tube, and it gives 10% of ozone. It gives 10% of ozone. Only 10% of ozones are formed. Other 90% of oxygen remains, or again it is used to preparation of ozone. Here, what is the uses of this discharge tube? The discharge tube, it is one reason is it supply heat. It gives the or it supply heat, and the reason of using discharge tube is studied, or it is better to understand the concept of discharge tube after the knowing the enthalpy of the reaction. Delta H of this reaction is positive. Because of that, it is nearly positive 142 kilojoule per mole. This delta H is positive. That means the reaction is endothermic. Reaction is endothermic reaction. Here, the reaction is endothermic due to that. Suppose you are already well known about the concept of reversible reaction and all that, the equilibrium and all that. This reaction is actually irreversible. The reason of reversibility is because of the instability of ozone. Ozone is highly reactive. That means it is less stable. Yes. Compared to oxygen, ozone is highly unstable. Therefore, it tries to again get converted into ozone or decomposes to use oxygen. Okay, ozone decomposes to use oxygen. That's the reason this reaction is reversible. Every reversible reaction has some equilibrium point, and this reaction is endothermic. Then what are the things needed for the manufacture of large quantity of ozone, and how to obtain ozone and all that? So just discuss about all these things. It is a reversible reaction. It is an endothermic reaction. Endothermic reaction means after formation of ozone, it is absorbed, cool, system become cool. So because of that reaction, if we not supply any amount of heat, suppose we don't supply heat in this case, then ozone directly decomposes. To prevent the decomposition of formed ozone, we use silent electrical discharge tube. Okay, that is the reason. It is called ozonizer, the apparatus, or what we use it to preparation of ozone. That one is called ozonizer, and ozonized product is nothing but ozone. Okay, so it is about the preparation of ozone. What are the things important here? The things are, one is it is endothermic reaction. Okay, it is that delta H is positive, delta H negative, or delta H formation of ozone is negative, endothermic reaction. We use electrical discharge tube. The reason of using the electrical discharge tube is because of preventing the decomposition of ozone. Okay. Next, compare the ozone and oxygen. Ozone is highly unstable and it is diamagnetic in nature. The molecule of ozone is diamagnetic and the molecule of oxygen is paramagnetic. Okay, that part you are already well known in the first year part, I think. Chemical bonding. Study about the, you are already study about these things, oxygen, nitrogen and carbon. So what is the magnetic property and all that? Ozone is oxygen is paramagnetic, molecule of oxygen is paramagnetic, ozone is diamagnetic. Okay, so these are the comparable thing between oxygen and ozone. Okay, next we move on to the properties of ozone. What are the properties of ozone? The physical property. First is physical property. Properties of ozone. Under the physical property, ozone is pale blue color. Okay, pale blue color in liquid state. Okay, liquid, pale yellow color gas. In a gaseous state, ozone is yellow color, pale yellow color, and in case of a liquid state, it is pale blue color. It has a boiling point, nearly boiling point of ozone is 101.8 Kelvin. Okay, 101.8 Kelvin. When you observe this boiling point, so it become liquid. Ozone become liquid below this temperature. The mainly ozone is stored, what we discussed in the previous cases. Ozone, when ozone is produced, it become unstable. Ozone is highly unstable in the earth crust. Because of that, carry of oxygen, ozone, or carry of or preserve the ozone is difficult. How to preserve this ozone? The manufactured ozone or prepared ozone was stored in the vessel surrounded by the oxygen molecule, and it is stored below this temperature. First it liquefies. Okay, liquefaction of ozone take place, gaseous state to liquid state. How much temperature is needed? Very low temperature. It is below 101.8 Kelvin. Below that temperature it get liquefied, and that liquefied ozone is stored inside the vessel covered by oxygen molecule. Okay, so these are the things needed. Therefore, very difficult to storage and the carry of the ozone molecule. Generally, if we need the ozone, then we go into the preparation method. First, we prepare the ozone. Freshly prepared ozone is used for the different cases. Okay, so this is about the ozone properties. And when we observe the toxic nature of ozone, it is a harmful gas. But the small concentration is not harmful, it's a harmless. Okay, if we inhale a small concentration of ozone, is not gives any bad thing in our body or in case of a human body. But when the excess means more than 100 ppm. ppm is nothing but parts per million. 100 parts per million of ozone, more than 100 parts per million of ozone may causes the death also. Okay, so because of the toxic nature, suppose we inhale the more concentration of ozone, that decreases the breathing strength of our lungs and all that. So therefore it is a toxic. Okay, ozone is toxic at more than or higher concentration. Lower concentration of ozone is not a toxic. Okay, it's toxic but does not use any harm. Next, the magnetic property. Under the magnetic property is a diamagnetic molecule. So these are the physical properties. Next, it is toxic. More than 100 parts per million is toxic. Next, what are the physical properties of ozone? Sorry, chemical properties of ozone. Ozone is a good oxidizing agent. What is the reason of this oxidizing agent? There is a possibility of asking the question based on this concept. Justify. Ozone is a good oxidizing agent. What is the reason of this oxidation property of ozone? And is a good oxidizing agent. The strength of oxidation is very higher than the oxygen also. The reason is ozone is unstable. It is unstable in atmosphere. Because of that, in atmospheric condition or a standard condition, it is unstable. Therefore, it decomposes to gives oxygen and nascent oxygen. Whatever the nascent oxygen is produced, that is a good oxidizing agent. It oxidizes many things. Therefore, it is a good oxidizing agent. Any colored compound is made to react with ozone. Ozone is not actually react. It undergo decomposes into oxygen or gives nascent oxygen that oxidize the color substance into colorless substances. So bleaching. So we observe the bleaching action. So this is the justification for the bleaching action of ozone. It is also possibility that there may be a possibility of asking the question on these cases, justify the bleaching nature of ozone and all that. Okay, what it make any colored compound become a colorless. What is the reason? The reason is ozone highly unstable, decomposes to oxygen and nascent oxygen. That nascent oxygen is oxidize the color substances into colorless. So this is the bleaching action of ozone. Has ability to oxidize many sulfides or leads and as well as iodine. Okay, iodide, better to call as iodide because I minus, the negative state of iodide get oxidized to iodine with the help of ozone. The reason is it is unstable. Okay, let us discuss a few examples of oxidation property of ozone. When lead sulfide, many sulfide ore get oxidized, and consider lead sulfide. When lead sulfide is react with O3, get oxidized into lead sulfate and oxygen molecule is formed. Very easy to balance the reaction. If we know the concept of decomposition of ozone gives oxygen. Therefore, one ozone molecule gives one nascent oxygen. Here lead sulfide take 4, therefore 4 molecules of ozone that react with this one and formation of how much? 1O3 gives 1O2, 4O3 gives 4O2. So this is the balanced chemical equation. So this is the very important reaction for your exam point of view. Balance the reaction. There is a possibility, more possibility of asking the question based on the reaction. There may be a possibility of asking the question like that. Place the question mark here or place the question mark here. Then it may be asking in different way. Possibility of asking the question is different. Okay, in a different way questions are asked. So therefore, please understand the concept of oxidation or oxidizing property of ozone. Next one, when I minus react with O3, I minus means iodide, react with ozone, or ozone when made to react with any iodides like potassium iodide and all that, then it got converted into I2, and whatever the water molecule is there, that converted into OH, and that's converted into. Now balance the reaction. Here 2 hydrogen, therefore I am multiplied to OH minus 2 hydrogen, 2 oxygen, 4, 3 into 1, 4. Okay, so this is the reaction. Here, what happened? Iodide get converted into hydrogen. This one is a very important thing. Ozone acts as an oxidizing agent. Okay, So these are the justification for or the example for the oxidizing nature of ozone. What is the conclusion of this? Ozone has capacity to oxidize the sulfides ore and iodides, potassium iodide and all that. So it is a good oxidizing agent. It shows bleaching nature. It has ability to oxidize. Therefore, mainly this ozone is used to oxidize the oil and all that. In case of oil become colored, then we treat the ozone to the oil, that oil become colorless, it look like a pure. So in or in greasy substances or grease, oil, so for that purposes or oxidize that purpose we use the ozones, okay, in bleaching action, and oxidize the oil and greases. Next, what is the structure? Then what is the structure of ozone? The ozone is a bent structure molecule. Oxygen, it shows resonance stability. What is the reason of existence of O3? The existence of O3 is because of the stability gained by the resonating structure. What are the resonating structure of O3? So this is the resonating structure of O3. Okay. The electrons move from this oxygen to this oxygen, so it gets stability. It is expected the bond angle is 117 degree, okay, and the bond length between the oxygen and oxygen in the both the side is same, okay, there is no change in the bond length. It is nearly 128 picometer. It is nearly 128 picometer. So this is the bond length and the bond angle of ozone. So these all are about the ozone. Okay, what are the things? Manufacture method or preparation method, structure, next property, physical property, chemical property, and the general things, general aspect of ozone. Ozone present in the stratosphere, it is far from 20 kilometer. And next is ozonolizer. Ozonolizer is the method of preparation of ozone. It is from oxygen, it passes through cell and discharge tube. And the next is it is endothermic reaction and all that. Next is the preparation and properties. Okay, so these are about ozone. Okay, the next thing is ozone depletion. So whatever the property we discussed and preparation method and all that, after that depletion of ozone, we know that thing, concept of depletion of ozone depletion. Ozone depletion is because of the several things. Ozone depletion takes place because of their highly instability. Ozone is unstable because of that. Whenever it is react with nitrogen monoxide, this mainly nitrogen monoxide that produced from the exhaust of the aircraft. When nitrogen monoxide is exhausted from the aircraft, that react with ozone, reaction is possible because of in the atmosphere. Up to the atmospheric level, it happened. O3 is react with nitrogen monoxide and again converted into O2 and oxygen is liberated. So that the concentration of ozone decreases, formation of oxygen increases. Because of that, layer slowly concentration of layer decreases. So this process is called depletion. It is because of the nitrogen monoxide and it is because of the freons. It is used in Prions, these are the polyhaloalkanes, prions, and these are exhausted or used in aerosols and refrigerator and all that. So because of prions, because of nothing but CFC, so and the nitrogen monoxide, the concentration of ozone decreases. That one is called depletion of ozone. And what happened in this stratosphere, whatever the oxygen is there, that oxygen, because of the heat from the sunlight, the oxygen combined and forms a ozone. When ozone is formed, it is endothermic, cool the system or decrease the temperature of the system. The heat from the sun decreases, quantity of temperature, also quantity of heat decreases, and ozone is formed. When ozone, in case of the ozone layer, the ozone molecule that react with UV light or bombarded from the UV light or to the UV light, ozone undergo decomposition and forms again O2. Amount of energy increases, heat energy liberated, while reversible reaction takes place. Ozone gives oxygen is exothermic, delta is negative, heat energy liberated. Again consuming heat energy, ozone get converted into oxygen get converted into ozone. Ozone again get converted into oxygen. So this case continuously happen that stratosphere. Okay, so that it maintain the layer, ozone layer. So it is general thing about the ozone. And because of the exothermic reaction, if we store the excess of ozone in one side, there may be a possibility of explosion. Reason is, when large quantity of ozone is placed in one's area, there may be a possibility of conversion of O2 because of by gaining the energy. It decomposes, easily decomposes, highly unstable, more reactive, therefore it undergo decomposition. It gives nascent oxygen and oxygen with the liberation of heat energy. If we store large amount of ozone, there may be a possibility of explosion. Okay, so this is about ozone. Okay, next we move on. Okay, so this completes the compounds of oxygen and ozone. Next we move on to the second element of group 16, this sulfur. The second element is sulfur. So in case of sulfur, again sulfur exhibits or shows allotropy. The allotropies of sulfurs. The meaning of allotropy? Allotropy meaning is as elements has same chemical property, shows different physical property. Allotropies of sulfurs are, there are two allotropies. There are two types. One is a rhombic sulfur. Rhombic sulfur. Second one is monoclinic sulfur. Monoclinic sulfur. Rhombic sulfur is also known as alpha sulfur, and monoclinic is also known as beta sulfur. Okay, monoclinic is known as beta, rhombic sulfur is known as alpha sulfur. So sulfurs are two types. Okay, these are known as allotropies of sulfur. Then what are the important properties of rhombic sulfur and monoclinic sulfur? The rhombic sulfur, nothing but alpha sulfur. Alpha sulfur shows some different physical property. Both have same chemical property. The reactivity is not differ, but the physical conditions or physical properties of these two sulfurs are different. Here, in case of a rhombic sulfur, The melting point of rhombic sulfur is 385.8 Kelvin. Okay, nearly 386. And the melting point of monoclinic sulfur is 393 Kelvin. 393 Kelvin. Please remember, these are the concepts are very important points about your exams. Okay, rhombic sulfur has melting point nearly 386, and monoclinic sulfur has 393 Kelvin melting point. Both these two show stability in different condition and different temperature. 369 Kelvin. This is the transitional point. More than 3, very important. Okay, more than 390 Kelvin, beta sulfur is stable. Beta sulfur is stable. Up to how much? Up to 393. At more than 393, it gets melted. And below 369, this one, alpha sulfur is stable below 369 Kelvin temperature. Below this temperature, alpha sulfur is stable. Above this temperature, beta sulfur is stable. Both allotropy sulfurs or states are, both state of sulfurs are stable at this point. Therefore, this temperature is called transition of this alpha to beta take place, transition state. Okay, what it concludes, there is a possibility of preparation of beta sulfur from alpha sulfur. Okay, yes, it is true. Beta sulfur or monoclinic sulfur is prepared from rhombic sulfur. So these allotropic nature is because of their structural arrangement or a packing. So what we discussed in the solid state, due to small change in the angle, there are 6 parameters, 3 edges, 3 angles. So small changes in their angles and edges that causes the different structure. One is a rhombic type of sulfur. These are sulfur, contain sulfur atoms, but the arrangement of sulfur is like a rhombic. And here this is a monoclinic. In case of a monoclinic, any one angle is same, correct? So any one angle, or there all the edges are different. Okay, here all the length ABC, all are different. Okay, so because of change in their structure, it forms a two allotropy. There is a possibility of preparation of rhombic sulfur to monoclinic sulfur when rhombic sulfurs are heated more than this one. Transition point 369 Kelvin. When alpha sulfurs are heated more than 369, it gets converted into beta. Suppose we heat more than 385, then that one alpha sulfur get melted. Then question is arises, how to find out the melting point of beta sulfur? It is more than 360, 393. More than 385 get melted. How? It is not like that. Okay, clear the concept? Okay, just once again I recall all the things. When alpha sulfurs are heated more than 369 in a closed condition, and it get converted into beta sulfur, and that whatever the excess quantity of liquid is there, that one is removed from that closed vessel, and needle like structure remaining in the vessel. That needle like structure is nothing but a beta sulfur. It is a monoclinic sulfur. Okay, needle like structure is observed, that one is beta sulfur. That beta sulfur is extracted, and when we observe the melting point of that beta sulfur, it is 393. Suppose we observe the melting point of, directly measure the melting point of alpha sulfur, it is 385.8 Kelvin. Okay, this is about the melting point and the preparation method of alpha and beta sulfur. Alpha sulfur is directly obtained. Okay, it is naturally occurring type. So these are about the manufacture method and the melting point. Then what about the solubility? Solubility, rhombic sulfur, alpha sulfur is soluble in carbon disulfide, readily soluble in carbon disulfide. Okay, so these are about the things. I would like to give one small work. Collect the differences between these two, rhombic and monoclinic, about solubility, about melting point, and the preparation method and all that. Okay, so collect any 3 points from different sources. One from this video, one from your textbook, and you collect the more than 3 from different sources, internet and all that. Okay, try to collect the differences. So this is about the sulfur. Next, what are the other form of the sulfur? These are 2 allotropies of sulfur. There are other type of sulfurs are there. Sulfur, it is exist in polyatomic state. It is S8. It is exist in polyatomic state S8, and S8 is a crown shaped sulfur. It's a puckered crown shaped structure. So like this. 1, 2, 3, 4, 5, 6, 7, 8. It's a puckered crown shaped structure. Suppose we join these 2 points, then it look like crown. So therefore it is known as crown shaped structure. It is solid. It is solid. Okay. S8 is not dominant. It exists in solid state. Another one is S6. Okay, these are all concepts are very important, but in your syllabus only headings and the main points are given. When we go in depth of these things, a lot of things are there about their structure, about their properties, all physical properties and all that. But these all things are not needed. There are several things are there. In your case or in PUC level, these all things are not given. Okay, so whatever things needed, that much I would like to give to you. Okay, so S8, it is a crown shape. Next, S6, it is chair type of, or it gets stability and the structure is chair shape. Okay, so this is the structure of S6. Again, it's solid. It is solid. It is solid. Last one, dominant structure or dominant species in the sulfur, it is S2. Very important. The dominant species, S2 is the dominant species in the sulfur, and it is exists in a vapor state, gaseous state. Okay, gas state. There may be a possibility of asking the question on these cases. Okay, in your competitive exam, not in your theory exam. Okay, about the structure and different form of the sulfur and different states, solid state, gaseous state. Which one is the dominant species in the sulfur? S2 is the dominant. Which one is exist in gaseous? Which form of the sulfur exists in gaseous? S2 form. S6 shows chair type. S8 puckered crown shaped species. Okay, so these are the very important concept under sulfur. About sulfur dioxide will be discussed in the next video. Okay, thank you for watching.